This video is for Homework and Mastery 2.7, Section 20.3 in your textbook, Absolute Value, Equations, and Inequalities. This is where we're going to solve and learn about absolute values and also absolute value inequalities and learn how to solve them. The absolute value of a number is the distance between that number and 0 on the number line. Here are the absolute value symbols, straight lines up and down, with the number in between. The absolute value of -4, we want to know the distance between 0 and -4. Well, the distance from 0 to -4 is a distance of 4. We went 4 places. So the absolute value of -4 is actually a positive 4, because when we're talking about absolute value, we don't mind if it's in positive or negative. We just want to know the distance. The absolute value of +5 is 5. When we're looking at solutions for an equation of the form absolute value of ax plus b is equal to c, what we're talking about is we want to set what is inside the absolute value equal to either a positive or a negative c. The reason why we want to look at the positive and the negative is because once we take the absolute value, it's obviously going to be positive. But until then, it could be positive or negative. For example, solve and check your solutions. We want to know the absolute value of z minus 15 equal to 23. Whenever I look at this, I already have the absolute value isolated by itself, which is always my first step. After I have it isolated, I need to set what is inside the absolute value bars equal to a positive 23 and to a negative 23, because my solution can be either or. Then I'm going to solve each equation. Z minus 15 equals 23. So I'm going to add 15 to both sides, and I get z is equal to 38. Then I look at z minus 15 is equal to negative 23, and I get z is equal to negative 8. So these are my two possible solutions. My solutions are negative 8 and 38. I always want to check them, and so I'm going to plug them back in, and I get the absolute value of negative 8 minus 15, which the absolute value, negative 8 minus 15 is negative 23. Absolute value of negative 23 is 23. 38 minus 15 is 23. The absolute value of 23 is 23. Therefore, these solutions do check out. The solution is actually both of them. So on these, you may have one answer that checks out, two answers that check out, or no answers that check out. Solve and check your solutions for the absolute value of 1/2 x minus 1 is equal to 5. Notice already that the absolute value is isolated on one side of the equal sign by itself, equal to 5. So I'm going to set what is inside the absolute value equal to a positive 5 and equal to a negative 5. Since this has a fraction, I'm going to multiply through on both of my equations by a 2. I'm going to multiply through by my common denominator. This will help me get rid of my fractions. When I multiply through, this 2 cancels out, and this will give me negative 1 times 2, which is a negative 2. 2 times 5 gives me 10. Over here, this 2 cancels out. 2 times negative 1 gives me negative 2. 2 times negative 5 will give me negative 10. I need to add 2 to both sides of the equal signs on both equations. So here on the left hand side, I'm going to add 2, and I'll get x is equal to 12. Whenever I add 2 here, I'm going to get x is equal to a negative 8. So here my two solutions are negative 8 and 12. When you plug these in and check them, the two solutions both check. So both of them are actual solutions to this problem. When an equation is set up where you have the absolute value of an area plus another number equal to another number, you must first rewrite it to where the absolute value is alone or isolated on one side first, which I've already been talking about a little bit. So for example, when I have absolute value of d plus 7 plus 3 is equal to 8, what I want to do is I want to get the absolute value alone first. So I want to rewrite the equation so the absolute value expression is alone on one side. How I do that is I'm going to subtract this 3 from both sides and get the absolute value of d plus 7 is equal to 5. After I have the absolute value alone on one side, that is whenever I separate it into d plus 7 is equal to a positive 5 or d plus 7 is equal to a negative 5. Now I can solve. I subtract 7 from both sides and I get d is equal to negative 2 or d is equal to negative 12 because I subtracted 7 here as well. I plug negative 2 back into my problem and I plug negative 12 back into my problem, and they both check out. So anytime that you have a problem and you need to isolate the absolute value first, make sure that you get the absolute value alone before you set it equal to the positive and to the negative. Now then, if you have an absolute value that's equal to an absolute value, what you have to do is you have to take the absolute value in one of them and set it equal to the other one's positive and equal to the other one's negative. Let's look at an example of this. I have the absolute value of the difference of m minus 1 over 2 is equal to the absolute value of 2m plus 3. Well, I already have the absolute values isolated from each other, and so I can just go ahead and set them equal to the positive and to the negative. So what I'm going to do is I'm going to set m minus 1 divided by 2 equal to a positive value of 2m plus 3 and m minus 1 over 2 equal to negative, or the opposite, of 2m plus 3. Notice I put the 2m plus 3 in parentheses. This way I distribute the negative and get actually the opposite of this. I'll go ahead and solve. In order to get rid of the 2 on the denominator, I multiply, and I get m minus 1 is equal to 2 times 2m plus 3. Going to distribute the 2, and I get 4m plus 6. I've also gone ahead and subtracted this, added this 1 to both sides, and gotten this m by itself. I now need to subtract the 4m from both sides, and I'll get a negative 3m plus 7. I got the 7 by adding the 6 and the 1. I can now divide by a negative 3, and I get m is equal to a negative 7/3. I'll follow the exact same procedure on the second equation. I need to distribute the negative and multiply by 2. When I do so, I get a negative 4m and a negative 6. Remember, I got the plus 1 by adding this 1 to both sides. If I add 4m to both sides, I get 5m. Negative 6 plus 1 gives me a negative 5. divide both sides by 5, and I get m is equal to -1. So my solutions are -7/3 and -1. Remember to always check your answers. Both of these do actually check out on this problem. Now when we're looking at the absolute value of an inequality, we have to think about this. If we want the absolute value of less than a number, what we're going to do is actually say that the absolute value is between the negative and the positive. So we're going to sandwich it between the negative and the positive. So if I have the absolute value of x is less than 5, the inequality means that x is less than 5 units from 0 on the number line. So we draw a picture. So it's 5 units on the number line, which means that x is between -5 and +5. I want to solve and graph the absolute value of y minus 15 less than 23. What this means, since I already have the absolute value on one side of the inequality by itself, I'm going to find a y value that makes the statement true for -23 is less than y minus 15 less than 23. To solve a compound inequality like this, whatever I do to one side, I must do to all three portions. So I'm wanting to solve for y and leave it in the middle. So I have -15. I want to add 15 to all three sides. And I show that here. I've added 15 to the left side, 15 to the middle, and 15 to the right side. This will give me -8 is less than y, less than 38. So that means y has to be between -8 and 38. And here it is on my number line, -8, 38, and I've shaded in between. Here's one where I want to solve and graph the solution of the absolute value of 2 times the difference of x and 1 plus 4 is less than 8. I'll solve this the same type of way, but I'm going to simplify inside the absolute value signs first. So I'll distribute the 2, and I'll get 2x minus 2 plus 4. I'll combine like terms, -2 plus 4, and I'll get the absolute value of 2x plus 2 is less than 8. Now, since I have the absolute value less than a number, I will set it in between its negative and positive value. Whatever I do to one side, I must do to all three, so I will subtract 2 from every side. This will give me -8 minus 2 gives me -10 is less than 2x less than 6. Now I will divide everything by 2, which will reduce down into -5 less than 2 less than 3. When I go to graph this, I will draw on the number line, fill in between -5 and 3. Whenever we're looking at greater than, absolute value is greater than, what we're doing is we want to know if it's greater than the positive or less than the negative. So we're going to have to separate it and look at two separate values. So the absolute value of x is greater than or equal to 4. This inequality means x is more than 4 units from 0 on the number line. We draw the picture, and we're looking at 4 units more than from 0, which means that we're going away from 0. So we go greater than 4 or less than negative 4. So the solution is x is less than negative 4 or x is greater than 4. So where I want to solve and graph the solution of the absolute value of w plus 4 is greater than or equal to 7, I will set it up as w plus 4 less than or equal to negative 7, or w plus 4 is greater than or equal to 7. I will subtract 4 from both sides, and I'll get w is less than negative 11, or I'll subtract 4 again and get w is greater than 3. And I can draw this on my number line. Notice they're closed circles because it had the equal to part. So the solution is x is less than negative 11 or x is greater than or equal to 3. So if you've noticed on the inequalities, we have to be careful as to which direction the sign is going as far as how we're going to solve it. If it's just an absolute value equals a number, we set it equal to its positive and equal to its negative. If it's a less than, we're going to sandwich it between the negative and the positive. You really have to watch your signs and then plug your numbers back in and check to see, once you graph it, think about it. Does positive 6 satisfy, or would 0 satisfy it? Make sure that your solutions are reasonable and check your solutions. If you have any problems, please contact one of us and we'll be glad to help you in any way that we can. Otherwise, make sure that you're working on your homework regularly and let us know how we can help you.